Hello students, myself Rashmi Vaishnav, Assistant Professor in IMS UC Ghaziabad University Courses Campus. Okay, so today we are going to start interpolation. It's a very important method and the theoretical aspect and its conceptual background we have already discussed. Now, today onwards we are going to start a very important method of interpolation. Okay, so I'm going to forward my first slide, that is interpolation. We have basically three types of interpolation. Number one is equal interpolation, unequal interpolation, and central values. For equal interval, we have different method. For unequal interval, we have again different method, and as well as for central values formulas, we have again methods. But today we are going to discuss a very important formula of unequal interval, and that is Newton's divided difference method. There are two methods in Newton divided difference method, and second is Lagrange's difference method. But today only, as I said, we are going to start, we are going to organize, we are going to be cover up only first method, and that is your Newton divided difference method. Now, what is Newton's divided difference method? Newton is the name of a mathematician who actually concised this, who actually developed this method. So on behalf of give the regards to him, so the name of the method is on her name. So the formula is basically fx is equals to fx naught plus x minus x naught f x naught x1 plus x minus x naught x minus x1 f x naught x x2 plus and so on. Now, what are the values of x, x naught, y, y naught? I'm just showing it. I'm just going to be explain it into my new slide. That is the basically this table is given to you basically, and the table is on the behalf of if xi, fi. This xi are the values which are already given to you, as well as fi, the values are again already given to you, x1, x2 and x3. Here the values start from x1, x2 and x3. Sometime in different questions, the values of x also started with x0, x2, x3. Similarly, with respect to x1, there is a y1 value. With respect to x2, there is a value y2. And with respect to x3, the value is y3 and so on. But if the value start with x0, the value is correspondingly y0 and so on. Here, where as we discussed in the last slide, fx0 x1 is equals to this. This is basically the sign on the difference operator. Basically, this is the sign of a difference operator. I am going to be highlighted it, yes, so that you can be easily understand. Yes, this one. This part is known as a operator which is used for divided difference. So this is the first, because the power of this is 1, so that's why it is called as first divided difference. Again, if we talk about this operator, here the power is 2, it means second divided difference operator. Okay, and when the power is when the power is increased, so we can say that first divided difference, second divided difference, third divided difference and so on. Okay, so now move on the second part, and that is a numerical problem. With the help of this numerical problem, you can easily understand what is basically the concept behind the process. Okay, the process is basically, first of all, let's read the example. By means of Newton's difference formula, find the value of f8. Look class, f8 from the following table. We have the sum, as I discussed earlier, we have the values of x and we have some values of fx also with respect to x. Okay, so the values of x are 4, 5, 7, 10, 11 and 13. And if you are observing, the values have some dissimilar. Dissimilar means there is no constant difference between the two successive values. That means if we will find the difference between 5 minus 4, we will get 1 definitely. But if we find the value of difference of 7 minus 5, yes, we will not get the 1. That means in this case, where we don't have the same difference between two values of x, in this case we are going to use Newton's divided difference formula. It's a very important formula. Okay, so now let's go for further about its solution part. So first of all we make the tabular representation. Now, what is tabular representation? This kind we have discussed in the previous slide. We have write in the vertical form the values of x. We have also write the value of fx in the vertical form. Now this is the major part. How do I get 52? Now, because this is the formula is all about Newton divided difference formula, that means we also use two methods and we also use two operations over here, difference as well as divide also. So first of all, we are going to find how to find the first divided difference, second divided difference, third divided difference, fourth divided difference. Now move ahead. So how we find the value of 52? Now the concept is behind. Let me show you another slide. Yes, this is the concept basically. In the next slide, I have already mentioned, I have already analysis how we get the value of 52, first divided difference, second divided difference, and third divided difference, and fourth divided difference. So how to get I 52? 52 I will get, we will just now move on the previous slide. First of all, just subtract the fx value, two successive fx value, like 100 minus 48 divided by 5 minus 4. That is the first divided value, That means again, yes. Now look, 100 minus 48 divided by 5 minus 4, and I will get 52 here. So this is the first value of the first divided difference column. If we talk about how do I get 97, so I will get 97 how? 294 subtracted by 100 and divided by 7 minus 5. So this is the way to how to get the value of first vertical column of first divided difference. I hope you understand. Similarly, so on. Okay, if we talk about quickly, we start with we talk about the last two values. And how do I get 49? How do I get 2028 minus 1210 divided by 13 minus 11. So look into this class. Yes, this is the value. This is the value of 409. How do I get? Okay, similarly, on the basis of tabular first column, first divided difference, we also find the second divided difference. From where? From till you will find the value till you don't get the single digit. But here, this is the special case. In this case, we get the 0. And if we divide or if we subtract to 0 altogether, so we will again get the indefinite number. So just leave it this. Okay, this is not a normal case. This is a special case in which we will get the same difference. Here you can easily see here 1, 1, 1. Okay, for the second divided difference, one major changes are there. Same, we will go for the just previously we will find the divided difference. Now, let's suppose here is 97 and 52. So how do I get? Now I will show you my analysis part in the next slide now. This 15 I will get how? 97 minus 52 divided by 7 minus 4. Now how this 7 minus 4? Just show me in my slide. 7 minus 4. That means when we go for the second divided difference value, we will skip single value. Keep this thing in your mind. When we go for the second divided difference value, we will skip the first value. We will skip the single value. Similarly, on the basis of this, when we will go for the another, that means you can say third divided difference value, we will going to be skips two values. So as we can say as we will move the highest values of difference table, we will also skip the n number of values into the x column. Okay, so on the similar basis, yes, so here again, now I think you understand how do we get this second divided difference table. Okay, so move on, third divided difference. How do I get 1, 1 and 1? So again, I'm telling you, showing my previous video, yes, previous slide. That means how do I get this one? I will get, how do I minus it? I will skip, now this time I will be skip 21 minus 15. Yes, it's okay. Okay, 21 minus 15. But at this time, because this is the third divided difference, so I'm going to skip the three values, and that is 10 minus 4. Same here, 27 minus 21 and divided by 11 minus 5. Similarly, the last one, 33 minus 27 and 11 minus 13. So if you see, after this calculation, I get this tabular representation. Okay. Last but least table. Now fourth divided difference table. Fourth divided difference table I will be get, and 1 minus 1. So again 1 minus 1, because both are same values, so we will get the 0. So we must need to stop over here. That means we find only the first 3 Newton's divided difference columns. Okay, now it's time to put these values into the formula. Okay, this is the formula, and we are going to find the value of when x is equals to 8. Okay, so this is the complete formula which will be discussed in our second slide. That is fx naught, x minus x naught, fx naught x1, x minus x. Here you observing there is a pattern between the values. Only fx naught in the first term, and in second term x naught x1 is introduced, in the third term x2 is introduced, in the fourth term x3 is introduced, and so on. Okay, and but how do we get how many terms we will use? And we will get this analysis by our tabular representation. Okay, in the you easily observe in our tabular representation we have only third divided difference. That means it is mandatory to use the formula up to third divided difference, which I'm going to be highlighted. Okay, so just wait. Yes, now it's our conclude part. We have the values of, or we have all the values. By using the tabular, we will put all the values into the formula, like 48 plus 8 minus 4 multiplied by 52, 8 minus 4, 8 minus 5 multiplied by 15, 8 minus 4, 8 minus, you are easily observed there the values are repeating over here. 8 minus 4 every time, every terms there is a 8 minus 4, then 8 minus 5, then 8 minus 7, and so on. Finally, we will get 448. It's my final answer. Okay, I hope this practical problem helps you how to understand Newton's divided difference formula.